All right, let's look at practice problem number 1 that's associated with sample problem A. In this problem, we are going to do some basics, talk about the difference, or remind ourselves of the difference between displacement and distance traveled. We're not going to get to the Pythagorean theorem yet, or the inverse tangent function yet, so we're not going to be doing a whole bunch of magnitude and direction questions yet. Okay, we're just reminding ourselves of the difference between displacement and distance. A truck driver is attempting to deliver some furniture. First, he travels 8 kilometers east, and then he turns around and travels 3 kilometers west. Finally, he turns again and travels 12 kilometers east to his destination. Well, the first thing we want to do is draw a coordinate system. Okay, it's very, very easy for beginning physics students to think that they have to be able to do these different things in their heads. They simply don't. Once you become very, very comfortable with these procedures, you might, and emphasis might, stop drawing something like this to help yourself. But until you are very, very advanced, please do this as you're trying to figure this stuff out. Because what we have to do is we have to establish our coordinate system. How are we oriented in this system? Now, by convention, when we use kind of the XY system, the right of the x-axis has a positive sign, and the left of the x-axis has that negative sign, and that's going to help us later. So first thing that the driver does is travel 8 kilometers east. Okay, east. So delta x. Okay, now if we want to make this a vector, because I can't really just draw it bolded, I draw an arrow on top, is 8 kilometers east. Fair enough. Next, actually I'll make that my displacement 1. I can then have my displacement 2. Again, arrow on top means it's a vector, not just a scalar. Traveled 3 kilometers west. Again, using kind of the cardinal direction system, west is going to have a negative sign convention. So when I say 3 kilometers west, this can also be represented as negative 3 kilometers east. That's the idea of a negative vector. Okay, I'm not traveling east, but according to the east direction, I'm traveling negative 3 kilometers. A third vector, which ends up being 12 kilometers east. And as you can see, these all have magnitude and direction. So they're vectors. That's why I've represented each one with an arrow over the top of it. But when we look to our questions here, A, what distance has the driver traveled? This is a scalar quantity. Whereas in B, what is the driver's total displacement? Okay, this is going to be a vector. So let's start with A. What distance? Again, no direction here. We're talking about total distance traveled. What distance has the driver traveled? So this distance is going to be just delta x1 plus delta x2 plus delta x3. But notice I'm not drawing the arrows over these representations because these are just scalars, right? There's no direction here. So what that's going to end up being, according to the values that I've already identified, is going to be 8 kilometers plus 3 kilometers. Again, not the negative 3 kilometers because we're taking into consideration direction, just the kilometers. And then 12 kilometers. Add those together, we come up with 23 kilometers. That is the total distance traveled. But B, what is the driver's total displacement? This is a vector, so we're going to be needing to take into consideration not only the magnitude, but also the direction. So now when I set up my equation, so now again I've represented it as a vector with that arrow over top. Total displacement, right? Subtotal, you can see that's why I have total, is going to be my first displacement plus my second displacement plus my third displacement. So I'm going to take these magnitudes in here, but I also have to include the direction. Okay? Now, numerically, east, west, north, south, they don't really help me much. But again, if I have established my coordinate system here, I'll be able to use this sign convention to establish my direction. So I'm going to assume we're referring to the east direction. So I will actually add 8 kilometers plus negative 3 kilometers to indicate that, in fact, it is going west, plus 12 kilometers. And when we add these together, we actually get 17 kilometers. And these are all in the east direction. Okay, so 8 kilometers east, negative 3 kilometers east, 12 kilometers east. These are all east. So when I add them together, I end up with 17 kilometers east. Make sure you create that habit in your final answer of including both magnitude and direction when you're being asked for a vector quantity.